So let sum 1 by 1.1 into 3 plus 1 by 3 into 5 plus 1 by 5 into 7 and so on. 1 by 2n minus 1 into 2n plus 1 is equal to n by 2n plus 1. Let S of n be the statement. So S of n is equal 1 by 1 into 3 plus 1 by 3 into 5 plus 1 by 5 into 7 plus and so on. 1 by 2n minus 1, 2n plus 1 is equal n by 2n plus 1. So case 1. If n is equal to 1, taking LHS, 1 by 2n minus 1, 2n plus 1, substituting n value 1, 2 into 1 minus 1, 2 into 1 plus 1, 1 by 2 minus 1, 1, 2 plus 1, 3, so 1 by 3. RHS, n by 2n plus 1, n value substitute 1 by 2 into 1 plus 1, 1 by 3, 2 1 is 2 plus 1, 1 by 3. So both LHS equal to RHS. S of n is true for n equal to 1. S of n is true for n is equal to 1. Next, condition number 2, case 2. Assume that S of n is true for n equal to k. So n replace k. S of k is equal 1 by 1 into 3 plus 1 by 3 into 5 plus 1 by 5 into 7 plus and so on. 1 by 2k minus 1, 2k plus 1, k by 2k plus 1 is equation 1. So simply S of k is true for n equal to k. S of k is true for n equal to k. So we show that case 3. We show that S of k is true for S of n, sorry. S of n is true for n equal to k plus 1. So write S of k again write the equation 1. One by 1 into 3 plus 1 by 3 into 5 plus 1 by 5 into 7 plus and so on. 1 by 2k minus 1, 2k plus 1 is equal k by 2k plus 1. Equation 1. So adding on both sides, adding on both sides. Please observe my red color. So please observe. K replace k plus 1. 2k minus 1. Substitute k replace k plus 1 minus 1. 2 into k plus 1 replace k. K replace k plus 1. 1 by 2k plus 2 minus 1. 2k plus 2 plus 1. So 1 by 2k plus 1, 2k plus 3. This is adding on both sides. So 1 by 2k plus 1, 2k plus 3. So s of k plus 1, 1 by 1 into 3 plus 1 by 3 into 5, 1 by 5 into 7 plus and so on, plus 1 by 2k minus 1, 2k plus 1 plus adding 1 by 2k plus 1, 2k plus 3. This is adding LHS and also adding RHS. K by 2k plus 1 plus 1 by 2k plus 1, 2k plus 3. So both side is common term. 1 by 1 k plus 1 by 2k plus 3. Okay, common term. One by 2k plus 1. LCM is 2k plus 3. Cross multiplication k into 2k plus 3 plus 1. Write down. Continue next step. 1 by 2k plus 1, 2k square plus 3k plus 1 by 2k plus 3. Okay. Splitting the middle term. 2k square plus 3k plus 1. 2k square plus 2k plus 1k plus 1. 2k common, k plus 1 plus 1 common, k plus 1. Finally, k plus 1 2k plus 1. So I will write numerator value 2k square plus 3k plus 1, replace k plus 1, 2k plus 1 by 2k plus 1, 2k plus 3. 2k plus 1, 2k plus 1 cancel. So k plus 1 by. So what is the answer now? Show that n by 2n plus 1. N replace k plus 1. K plus 1 by 2 into k plus 1 plus 1 is satisfied. So by last line, by mathematical induction, by using, so S of n is true for n equal to k plus 1 by using principal mathematical induction. S of n is true for all n belongs to capital N. Write down. Next problem. 4 cube plus 8 cube plus 12 cube and so on up to n terms. Nth term is not given. Up to n terms is equal 16n square into n plus 1 whole square. So what is observer? Sum of square of cube of numbers. So let S of n be statement. What is observer? 4 cube plus 8 cube plus 12 cube. S of n equal to 4 cube plus 8 cube plus 12 cube. Sum of cube of numbers. The multiple of 4. Multiple of 4. That means 4n whole cube. Multiple of cube is equal 16 n square n plus 1 whole square. So please observe 4 cube, 8 cube, 12 cube. So I will write 4 cube is common. 1 cube plus 4 2 jar 2 cube, 4 3 jar 12. Okay, already explained yesterday. This is the n cube. So simply write 4n whole cube. 4n whole cube. Same case 1. If n equal to 1, LHS 4n whole cube. 4 into 1 whole cube. 4 cube is equal 64. RHS 16 n square into n plus 1 whole cube. 16 into 1 square, 1 plus 1 whole square. 16 into 1 plus 1, 2 whole square, 4, 64. Both LHS equal to RHS. Case 2. So same. S of n is true for S of n is true for n equal to 1. Case 2. We assume that S of n is true for n equal to k. Just n replace k. S of k is equal 4 cube plus 8 cube plus 12 cube plus and so on 4k whole cube 6k square into k plus 1 whole square. S of k is S of n is true for n equal to k. Case 3. Show that S of k is true for n is equal to k plus 1. Again write the equation 1. S of k 4 cube plus 8 cube plus 12 cube plus and so on 4k whole cube 16k square k plus 1 whole square. So adding on both sides, observe the LHS value. Observe LHS value 4k whole cube. K replace k plus 1 whole cube. K replace k plus 1. So 4 square, 4 cube. 4 cube. K plus 1 whole cube. 64 k plus 1 whole cube. So adding on both sides 64 k plus 1 whole cube. S of k plus 1 4 cube plus 8 cube plus 12 cube plus and so on 4k whole cube plus 64 k plus 1 whole cube is equal 16k square k plus 1 whole square plus 64 k plus 1 whole cube. What is the common in both two terms? The common value 16 and k plus 1 whole square is common. So k square plus 16 4 ja 64 remaining k plus 1. 16 k plus 1 whole square k square plus 4k plus 4 1 ja 4. Simply ma 16 k plus 1 whole square split the term k square plus 4k plus 4 k square 2k plus 2k అని రాసుకోవచ్చు లేదా డైరెక్ట్ గా plus 2 square a plus b whole square k plus 2 whole square. So what is the answer? 16n square into 16n square into n plus 1 whole square. So n replace k plus 1 is coming and k plus 2 write as k plus 1 plus 1 whole square. So satisfied. The equation is satisfied. Write down last line. S of n or S of n is true for n is equal k plus 1 by using principle mathematical induction. S of n is true for all n belongs to capital N. Write down. Write down. A plus D, A plus 2D, plus and so on up to n terms is equal n by 2, 2a plus n minus 1 into d. So n term is not given. N term is not given. So what is the n term? Already studying ma. A plus D, A plus 2D plus and so on. Nth term is an equal to A plus n minus 1 into d. So let S of n be statement. S of n is equal A plus D plus A plus 2D plus and so on. The nth term is A plus n minus 1 into d is equal n by 2, 2a plus n minus 1 into d. Okay, case 1. If n equal to 1, LHS a plus n minus 1 into d. A plus 1 minus 1 into d. A plus 0, A, RHS n by 2, 2a plus n minus 1 into d. N by 2, 2a plus 1 minus 1. D. So D 1 by 2a plus 0. 2 cancel, that is the value A. LHS equal to RHS. S of n is true for n equal to 1. Next one. Case 2. Assume that S of n is true for n equal to k. So n replace k, a plus d, a plus 2d plus and so on. a plus n minus 1 into d is equal to n by 2. N means k. 2a plus k minus 1 into d. Equation 1. So S of n is true for n equal to k. True for n equal to k. Case 3. We show that S of n is true for n equal to k plus 1. So write the equation 1. a plus d plus a plus 2d and so on. A plus k minus 1 into d. K by 2. 2a plus equation 1. Adding on both sides. So k replace k plus 1. Please take LHS. K minus 1 into d. K replace k plus 1 minus 1. So plus 1 minus 1 cancel. A plus kd on both sides. A plus kd on both sides. Okay. A plus kd on both sides. A plus kd on both sides. S of k plus 1, a plus d, a plus 2d, and so on. A plus k minus 1 into d. Adding on both sides. A plus kd. LHS adding and also RHS adding. So k by 2, 2a plus n minus 1 into d. A plus kd. So LCM by 2, k into 2a plus n into d, nd minus d plus 2 into a plus kd. So 2ak plus knd minus kd, 2a plus 2kd by 2. So 2ak plus 2a plus sorry ma k mark k into k square d k into k square d. So 2a plus I will write order k square d plus minus kd plus 2kd plus kd by 2. So what is the common? 2a is common, k plus 1. kd is common, k plus 1 by 2. So k plus 1 is common. 2a plus kd by 2. So what is the RHS? n by 2, that means k plus 1 by 2, 2a plus n minus 1 into d. So that is 2a plus kd n by 2, 2a plus n minus 1 into d. So I will write k plus 1 by 2, 2a plus n minus 1, n k write as k plus 1 minus 1 into d. So satisfied. Right now. So therefore S of kn is true for n equal to k plus 1 by using mathematical induction. S of n is true for n for all, true for all n belongs to capital N. Okay, right.